everyone. Today we're going to finish out solution stoichiometry. We started these conversions yesterday, but I wanted to hold off on the very last part of this lesson because I want to make sure you really understand it. We're going to be doing this in lab, and this is actually a technique that we've done at least 4 or 5 times in my college class. So I want to make sure you really understand this part of this lesson. So this part involves something known as titration. So to determine the concentration of a particular solute in a solution, chemists often carry out something known as a titration. You're going to be doing this later on this week. A titration is defined as combining a solution where the solute concentration is not known with a solution where the concentration is known. There are kind of 2 major definitions to understand from this, and the first one is called a standard solution. This is the known concentration in a titration. When you do your pre-lab questions, you'll actually learn a more descriptive term for the known concentration. But for this point in this lesson, standard solution is fine. Next is equivalence point, and this is the point in which stoichiometrically equivalent quantities are brought together. So that means equal amounts, stoichiometrically equal, of your one solution plus your other solutions are going to combine. Oftentimes, you are going to see titration problems written as such. 45.7 milliliters of a 0.5 molar sulfuric solution is required to neutralize 20 milliliters of sodium hydroxide solution, and it's asking what is the concentration or molarity of your sodium hydroxide solution. So notice here that unlike all these other problems, we're not asking for liters or grams or moles. We're looking for concentration. That should be the dead key giveaway that this is going to be a titration kind of problem. Oftentimes, I told you to start with anything other than molarity. So most of you guys started with milliliters, liters, grams, or moles. This is why I held off on this problem, is because there's an additional step you have to think about when you guys choose to, what do I start with? First, you're given 2 sets of milliliters here. How do you know which one to start with? You're going to start with the milliliters that is attached to your molarity. So for example, this 45.7 milliliters is attached to this molarity value. So that's how we know we're going to use this 45.7 milliliters first. So we're going to start with 45.7 milliliters, and this is of H2SO4. Now we can't ever do anything in milliliters, so we need to make sure we can get it out of milliliters, and we do that by converting it to liters first. So milliliters on the bottom. Remember, there are 1,000 milliliters in 1 liter. Once you get to this point, we can go from liters to moles. So 1 liter can go to the mole value. Now remember, to go from liters to moles or moles to liters, we need to use this molarity. So this molarity can be written as 0.5 moles over 1 liter. So notice I've canceled my milliliters, I've canceled my liters. Now I'm in moles of H2SO4, but I eventually want to get over here to the molarity of sodium hydroxide. Once you get it into moles, you can use your mole ratio. Again, this comes from your balanced chemical equation. If I want to cancel out moles of H2SO4, it needs to go on the bottom. And you want to get to moles of NaOH, sodium hydroxide. I'm going to look at this balanced equation, see that sodium hydroxide is 2, sulfuric acid is 1. So this cancels out moles of H2SO4. Now remember, molarity is moles divided by liters. So this is where it gets a little bit different. We want this mole value. We don't want to cancel it out. We need it. But we need to divide this by liters. So we can take this 20 milliliters and change it to liters first. So remember, to go from 20 milliliters to liters, you need to divide by 1,000. So if you take 20 divided by 1,000, you get 0.02. So we can set up this conversion by dividing it by 0.02 liters. And there's nothing going to be up top, and this is what throws everybody off. There's nothing up top, because I want my units to cancel out where all I have is moles divided by liters. So I've canceled out these milliliters, I've canceled out these liters, these moles. Now I have moles of NaOH and liters of NaOH. And remember, molarity, moles divided by liters. And then we're going to equal this out. There's going to be nothing up here. We're going to leave it blank. So we're going to plug in as our calculator 45.7 divided by 1,000 times 0.5 times 2 divided by 0.02. And this is going to get me the number 2.285. Now, if I look at my sig figs, I'm allowed to have 3 sig figs, so 2.29. And then I need to make sure I have my unit. This is concentration, so it's a capital M for molarity of NaOH. Let's do one more example problem, and then you guys can go ahead and start your homework. This one's asking, what is the molarity of sodium hydroxide if 48 milliliters neutralizes 35 milliliters of a 0.144 molar sulfuric acid solution? Notice here you have 2 milliliters. Remember, you're going to start with the milliliters that is attached to your molarity. So we're going to start with this 35 milliliters over here. And this, of course, is still H2SO4. We got to get it out of milliliters. So here there are 1,000 milliliters for 1 liter. This cancels out my milliliters of H2SO4. Once you get it into liters, you can cancel out liters. And you can go to moles. Now, remember, moles over liters is molarity. So we can actually rewrite this problem as 0.144 moles always over 1 liter. So this helps me cancel out liters of H2SO4. And now I have moles. But I don't want to be in this compound. I want to be in NaOH. So remember, to go from one compound to another, I need to use mole ratio. So I can cancel out this moles of H2SO4, and I can go to moles of NaOH. Remember, we're going to be using our balanced chemical equation for the numbers out front. So here's 2 moles of NaOH, and then over here I have 1 mole of sulfuric acid. This allows me to cancel moles of H2SO4. Now, the most obvious answer is to try to cancel sodium hydroxide, but I don't want to do that because I need the molarity. And remember, molarity is moles divided by liters. So I need moles of NaOH, and I have that, so I don't want to cancel it. What I want to do now is I want to take this moles that I found and divide it by liters. Well, the way we get those liters is from this 48 milliliters. Remember, we can change this 48 milliliters to liters by dividing by 1,000. So if you divide by 1,000, you can get 0.048 liters. So I can divide this by 0.048 liters of NaOH. Note, I have my moles of sodium hydroxide and my liters of sodium hydroxide, and they're opposites because I want moles divided by liters. Note there's nothing up here. You don't have to write anything up there. If it makes you feel better, you can put a 1 up there, but you don't have to. And then we're going to go ahead and equal this out. 35 divided by 1,000 times 0.144 times 2 divided by 0.048, and you get 0.21. So I'm going to double check that just to make sure my answer is correct. And I still get the same answer. Note here I have to have 3 sig figs. So we're going to write 0.210. Note that I'm looking for molarity, which is a capital M. And then my compound that I'm working with, NaOH. I want to make sure I have that since I'm working with multiple compounds. And my concentration would be a 0.210 molar solution of sodium hydroxide. That's the end of today's lesson. If you have any questions, please make sure that you come up and ask. And otherwise I hope you guys have a great day.